And we have people here. So
Woohoo! Hello.
What we had, yeah, Imp is here. And let's see if anybody else shows up.
Do the buttons on the Tree of Life badge have pull-ups, or are you using the?
I don't think we added resistors to the button.
Oh, cool. Okay, so if I can, if while you're teaching the class, if I can get them to work on my Tree of Life badge, then I can give you the code to use in the class to teach.
Okay.
Yeah.
I'll work
just something
on that,
simple that'll blink the onboard LED, on for one button, off with another button.
Cool.
All right.
I'll do that. I'll work on that.
So
so now I will mute myself.
Okay. We'll start from the beginning today. Very basic breadboard stuff, because last week was all about Thani, and we still got a couple more Thani things to cover, but we'll cover them in context. The main thing you need to is there anybody here at all who's never worked with a breadboard and wants a little bit of breadboard background? Raise your hand, type in the chat, whatever magic stuff you do, because I'll skip it if nobody needs it.
I haven't worked with a breadboard, but
Okay,
I
good
can
enough.
tell how it works by just looking at the rails on the underside.
Yes. Okay. Well, not everybody can tell, so we'll go through it. So I don't have one loose handy, but I can point with a pointer. Let me get a pointer out. So a breadboard. Let me get so I can see my screen. All right. So I've got this ring kind of partially blocking this breadboard. The center, the groove in the center, is a divider. Everything that has more than one leg is going to straddle that center line. So you're gonna use it from the left side or the right side of that groove, right? And so if you have an 8-leg chip, it'll go vertical, 4 legs on one side of the groove, 4 legs on the other side. And you want to leave room so that you,
sorry, go ahead.
Horizontally, depending on how you put how you have your breadboard laid out, right? So in line with the groove.
Yeah, I see you've peeled the back off of your board, right. And so you can actually see that starting from that groove that Bob was talking about, radiating out to the edges, each one of those rows are interconnected. And then exactly. So if you plug into any one pin in that row and plug something else into another pin in that same row, they are electrically connected. And then the 2 rails that run the length, the red rail and the blue rail, they run the other direction. And so typically you run power and ground down those.
Okay.
So if you've got something that has pins that are in line with each other, you need to straddle that thing in the middle, that row in the middle, so that the pins don't short together.
Good to know.
And on Bob's board, the button right there is a good example of that. He's got it, 2 legs are on one side of the channel down the middle and 2 legs are on the other. And so you've got access to all 4 pins separately, and you'll be able to use little jumpers to connect to those.
And the practice that I think most people use is power goes closest to the red line on the side rail. I can't point to that from here. There we go, the red line. And ground goes closest to the blue line. And those are, like Braden was saying, vertically connected. So it's easy to tap into power anywhere on your strip. Although in these longboards, I think mine might be split in the center as well.
Yeah, I'm looking on mine. It does seem to have a gap right down the middle for the power lines.
If that's the case and you've got a longer circuit, you just use a short jumper to jump from one side to the other to maintain the continuity if you need power on the upper side of the board or ground on the other side of the board. So all that makes sense, all that fit,
Makes sense
anything
to me.
missing? And anybody feel free to use the chat thing and someone will point it out to me if I'm not looking at it, if a question comes up. So this is recording, correct? Anybody confirm that? Okay. All right, so that's the basics of the breadboard. We'll get into now how I wired this sample setup. And let me get my camera back to where I want it. All right. All right. So I took from the Pico, there's a pin called 3v3 out, and that's your external power pin. And don't confuse it with 3v3 EN. That's something very different. That's something to use. I think it's used to turn on and off the Pico programmatically. So I ran 3v3 out to the red rail. And then I took from the red rail, I don't know if you can see that. Can you see that? Am I focused in on that at all? From the red rail, I go to the power connector on the NeoPixel ring. And another convention is using red cables for power and black cables for ground if you have them. It's just a good practice to use the same thing all the time so that you have a better picture of the circuit when you're looking at it. And you know, some people have more conventions and someone will probably pipe in with more conventions. So all you need for a NeoPixel ring is power from the red rail into the power connector, ground from the blue rail into the ground connector, and data in, which I connected to GPIO 5 on the Pico. And for those three, back to my Thonny window, I have a very basic NeoPixel demo that I guess I'll paste this whole demo in it. And I think it's changed. I think with the current version of Pico, you don't have to import a NeoPixel library in the same way, but I ran out of time and didn't find that particular demo, and this one works. So I'll paste this into the chat. Hopefully it pastes. Chat. If it doesn't paste well, someone else could figure out how to do that. Paste. Yeah, I can't paste it. I don't know what's going on. It's not letting me paste.
Are you able to paste the link?
I don't have a link.
Can you share your Thonny window, Bob, for a quick second?
Is it not already shared?
No, we're seeing the breadboard.
I could have sworn I shared the Thonny window because people were looking at my code earlier.
Maybe I'm not seeing it.
Back to Zoom. Yes, I am sharing the screen. Does anybody else not see the Thonny window?
I do not see it.
I don't
Alright.
either.
All right. Where did my Thonny window go? Thonny.
There we go.
Okay.
Thank you, Bob. That's good.
I must have hit stop share at some point without realizing it. Sorry about that. So I have this basic NeoPixel demo, and if I click it, sometimes it works. Nope, I must have broke it. It was definitely working earlier. Oh, yeah, that's why. Lost the pin number. All right, so yeah. So with 3 wires from the Pico, power, ground, and data in, it's controlling that whole ring. And you probably see it already, right? It does. They're all individually addressable. You can make any pixel, any color at any time. These are just a few of the built-in demos in the demo found on the MicroPython site.
Yes, so this is part of the traditional way that MicroPython released the NeoPixel for the Raspberry Pi Pico, where we're using some really low-level code. I won't get too much into it.
It's assembler. It's ugly.
It is. But today, there are newer versions where you just simply import NeoPixel. This is something that Braden and I were talking about earlier in the channel that I hope nobody got discouraged by the deep back and forth, but there are easier ways to import these NeoPixel libraries and then just simply address the actual NeoPixels and change them to any color that you want. So this is one way to do it. There are easier ways to do it, and I'll leave it at that.
The annoying thing about the easiest ways to do it is that it just came about within the last year with 1.19, and it's kind of hard to find examples on the net unless you know what you're looking for.
Right.
Every example on the net is for the last 2 years, which uses the old PIO with a chunk of assembler in the code, which is ugly. It looks like that. No, that's not it. It looks like that. Nope, that's not it. There it is. That's the ugly part. Actual assembler. You're actually you can tell all your friends that you program in assembler. Right, Kevin?
Yes, that's right. Yes.
So that's that. I wanted to stop for a second and talk about managing files in Thani, because it was brought up that wasn't covered well enough in last week's session. If you see on the left side of my screen, can you see the file browser on the left? Okay, so you can, the top half of that is where you can browse to a directory on your computer. And when the Pico is connected, that shows up in the bottom half of that. And that is enabled within, where? Is that in preferences? Options? Maybe it's in options. Yeah, I don't remember where exactly that's enabled, but once you enable it, just leave it there all the time, because, oh, maybe it's files.
Yeah, I think Betsy, you and I went through this. I think it's files.
Is it files?
I believe so. Betsy, do you remember?
There, yeah. I just turned off files and it disappeared. So yeah, few files. It's so much nicer that way. And your stuff won't show up right away if there's a program running. So there, hit stop. And then so when you save a file, let's say I make a new file in Thani. It's difficult to work with all these windows open, but this is a new file. Then you go to save it. It's going to ask you first where you want to save it, to your computer or directly to the Pico. Probably the best practice is to save it to your computer and then upload it to the Pico, because that way, if you forget and blow away your Pico or burn it out or whatever else, you don't lose your hard work. For this class, I'm just saving to the Pico. Save. It shows a list of the files that are on there. Call it new file.py. Bang. I saved my file to the Pico. And it stays open as a tab on your Thani screen. So you can flip-flop back and forth to different sub-programs and modules that you have. If you remember from last week, main is the main module that runs when you boot your Pico, if you have it. If you don't have it, I guess it'll do nothing until you tell it to run one of the programs. In my case, main is just the Blink program. So if I unplugged my Pico and plugged it back in, it would just be the onboard Blink. And the lights are still on because I didn't turn them off, right? The LEDs. But if you can see, yeah, you should be able to see my Blink going on. But like I said, unplug it. It takes the power away from the LEDs, takes power away from everything, because all the power is routing through the Pico. Plug it back in, and I just have Blink, right? So that's Blink, and that's NeoPixel basics. And breadboard basics, and Thonny file management basics. And once again, I don't see my Thonny files because it immediately started running a program, my main.py. So I hit stop up here, and my file directory shows up down here. So any questions, anything more in depth anybody wants?
So on Windows, how do you get the files window to pop up? I didn't quite see that.
Let me see. I think I have Thonny on my Windows machine behind me here. Hold on.
All right, thanks.
I have my Windows machine behind my laptop, and it's only displaying the Pico pinout, which when I'm doing this stuff, I can't see very well.
Yeah,
'cause
so
I'm old.
so in Thonny on Windows, if you go up to the View menu, you'll see an entry for files, and there probably is not a check mark next to it.
I got it. Yep.
Okay, so
check,
it is the
and
same.
you'll get that section over on the left side.
All right.
And Bob,
Thank
I've got your demo for you when you're ready.
Okay, that's great. Any other questions on the stuff we've covered so far? If not, we'll move on to the
There
display.
was one question in the chat.
Okay.
Is the ring controlled by one wire?
Yeah,
Yes.
I answered that in the chat, but
Oh,
it may not have
thanks.
been there. That's all right.
Yeah, the data in is one pin, and that is for a ring of 16 or a strip of 100. It, you know, I have controlled a strip of 100 from a Pico.
If I can add something quick too, real quick. So
Please.
yeah, so yes, it is controlled by one pin, and regardless of how many LEDs there are on the NeoPixel ring, you would actually reach out to them, or what we call address them, through what we call in MicroPython a list or an array. If you're, used to more traditional languages, so like the very first NeoPixel that is connected closest to the power and ground in the pin is going to be 0, right? And then they go from 0 up to however many pixels there are on the physical device minus 1. So if there's 16, you go 0 to 15. Does that make sense?
Yeah, but I was talking about the protocol. I don't know if it's using over the one-wire protocol or proprietary one, because it depends on which LEDs you're using.
It's using the one-wire protocol behind the scenes.
All right, thank you.
Actually, I think when you say one wire protocol, you're talking it's a very specific timing protocol for one wire.
Yeah.
NeoPixel actually it's running at like 400 hertz or something. There's a timing thing in the datasheet which you don't need to know about, but the low level code for the NeoPixels knows how to oscillate that one signal or one data wire such that LED 0 turns on green and LED 1 turns on red and LED 2 doesn't turn on at all, etc. And so that's all embedded in the timing of the code that's down at the lowest level. So if you were to take like a one wire sensor, you wouldn't be able to drive NeoPixels with that.
Right.
Okay, so it's similar, but timing is different.
Yeah, so it is one wire lowercase, not one wire protocol.
Okay. Yeah, I was getting confused in that. Thanks.
Yep.
And if you look at the Thonny screen I'm sharing now, at the level that we're using at, you're basically sending each pixel a small list of 3 values, and that could be 4 values if it's an RGBW pin, I think, pixel, I think, but essentially you're sending a red value, a green value, and a blue value. And
So
go ahead.
I hate to interrupt, but I'm not sure if you can see on my screen, but I've got it working now.
Yay!
And I found out how to get it working through this link right here. It's similar to what you were talking about before, but you basically write to a list and then write it to the actual NeoPixel.
That's what I was trying to.
The example. Yeah, I was gonna say, that's the example that I used. And it was the basis of my question to Kevin earlier. And this is I think Kevin can confirm this. This is the newer way of doing it, which is a little more intuitive. The key piece there is if you look at the import where it says import machine, comma, NeoPixel, that's bringing in the NeoPixel module that then gives you all this capability. And so there you have to go, you have to define, create your object, that's NP equals NeoPixel machine pin, etc. And then yes, at that point, you've just got an array that you can assign color values to. And then if you look down in the lower section in the demo code, the last thing you have to do is do NP write, or you do the write method on the NeoPixel object that you've created.
And you were able to use this out of the box, even though the link shows that it's designed for an ESP8266.
Yes.
Yeah,
Yep.
matter of
That's
fact,
great.
that demo code right there is the example I used to find the timing that Kevin and I were discussing.
Okay, so what I'm going to do, since you guys shared that in chat, I'm going to go ahead and put it on my Thonny screen.
I'm gonna
don't
see
know-
if I can
I don't know
write
if
the code to light all of them up.
I don't know if the Thonny screen is saved in the recording or if it's just the video in the recording. I might have to share this after the fact for the recording for the people that missed the
You can always
real-time
text it.
event.
There we go.
Maybe drop it into the Discord channel because everybody's kind of centered there in between classes.
Here's
Okay,
the
I'll
code
take
if
care of it.
anybody wants to copy paste it
Where'd you
Cool.
put it?
into the
Discord?
Zoom
The
chat.
Zoom chat.
But
in the
I
Zoom
will
chat,
put
cool.
the link into the Discord chat.
That actually is there you go. Yeah, that actually is the example. So Bob, would be good for you is to take this example and then show how you can use a loop to do that same end result, and instead of copy paste the line all the time. So give people a chance to look at what a loop can do.
And for the number that the pin out, it's going to be on pin out 1 for the data line. And then you can just use a ground and a power from any other side of the Pico.
That's assuming you're using GPIO 1, right?
Yeah, just in his
it is
example.
using GPIO 1
Okay.
for
In
this
his
one.
example, whatever Bob may use. Or did we lose Bob?
No, I'm here. I'm looking.
Okay, cool.
I'm looking at the I'm looking at the code. So what this does is set the first pixel to green and then the rest of them to blue.
Yep.
Am I looking at that right?
That's exactly what-
Green and then red.
Actually,
green,
technically,
red,
yeah.
then blue.
Yeah, the first one is 25500. The
Oh, I
second
missed the
one
first
is,
one. I didn't scroll that high. Okay.
yeah,
So
the
red
next one is
full, green half, and then blue quarter brightness.
Oh, they're
for all
all
the rest.
at the same brightness. I don't know.
Well, visually, yes, but electronically, no.
Of course.
And that's what those values are. And yeah, they NeoPixels are pretty damn bright.
Yeah. So in the example that you just did, the 3 values, so let's say you've got 0, 0, and 64. That's saying that out of a maximum of 255, your red is at 0. And out of a maximum of 255, your green is 0. And out of a maximum of 255, your blue is 64. So you're saying no red, no green, and 1/4 of your maximum of blue. And if you look at your NP of 1, you're saying no red, 128 out of 255, or 50% of green, and then no blue. And then your first one is saying 255 out of 255, which is 100%, 100% red, no green, no blue.
Am I misremembering? I believe I remember that all the NeoPixel documentation says nominal voltage 5 volts. Am I wrong there?
I thought it was.
It does
Yeah.
say nominal voltage is 5 volts. However,
We've been doing great with 3.3.
Well, the tiny NeoPixels do great at 3.3. They're more than happy at 3.3. The bigger ones do have a problem. They will kind of get by at 3.3, but they're much happier at 5.
Like the 5mm ones.
Yeah,
Okay.
the classic 50/50s, which I think is what's on that ring.
I mean, they're doing fine at 3.3.
Yeah, yeah. And like I said, I'm using the Tree of Life badge for all of my class exercises here.
That's cute. All right. Anything else before I don't
Well-
want to drop this into place and try it because it's complicated because it's loading the built-in NeoPixel and I've got a NeoPixel on the Pico now and I kind of have to disrupt everything and delete things.
We'll just
make-
create a new main.py file.
Right, but then I'd have to kill the NeoPixel.py that's on my board now. I guess
I don't think you do. I think it's going to load a different NeoPixel, but maybe not.
You have to change where the pin is in
Yeah, I know
the
that.
NP, but
Yeah.
okay. Should work.
Or are you talking about because you've got a NeoPixel.py file on your Raspberry Pi Pico already?
Yes,
Just rename
which
the
I'm
extension.
assuming it takes precedence if I have one local.
It
Yeah,
will,
just-
it will, it will.
Just
take
rename
precedence.
just rename the extension on that temporarily to NeoPixel.px.
No. Yeah. I'm also having trouble.
Because
with
actually
the-
this example is a really good one because we can see the example and then we can talk about some of the basic MicroPython things like how to do a loop and stuff like that to make this code smaller.
And of course, it does not import.
No space, no white space.
Yeah.
Sorry, that's
I
fine.
can make this happen.
Yeah, you're smart enough to make it happen.
I mean, I know what I'm looking at, right?
Very funny.
I might miss one or two, and I've got quite a crew that's willing to correct me here.
Yeah,
So
look for NP bracket as your break to figure. There you go. Now you find all your breakpoints.
You probably don't need anything past 2.
Well, but
Yeah.
actually, yeah, I mean, the good news
Unless
is
we-
pretty soon you're not going to have any more. Yeah, see now you don't have any more comments in there, so he can just punch right through the rest of those.
oops.
Um,
Oh,
Yeah, I had to
each.
do that too.
I just like this example because we can run this example and then we can make changes to it and see how, some of the basic features of MicroPython encoding allow us to.
I wonder what.
I prefer this example because we need to do away with the old add your assembler to the code bullshit.
Well, I was also referring to the ability to do things like explain how a loop can do some of this with less code. So I would run this first and make sure that everything. So can we see your?
These
Do you have your
LEDs
rings?
get-
Do you have your ring, Bob? Is your ring set to pin 1, or is your ring on some
No,
other
I have
pin?
to change that. I just pasted it.
Oh,
I
okay.
haven't changed it yet.
Oh, there we go. Cool.
There we go.
Okay.
Hey.
Woohoo!
Probably can't see it because of the glare.
Oh
if I
no, I
turn
can
the
see.
I mean, it's hard to discern because of the glare, right?
Oh yeah.
You
So
can definitely
if we
see
cut
there's
these
a couple
values
of colors.
down even 4, so if we put
go.
64, 32, and then the rest at 64 and run it again, then it's not quite as much glare. It's
There
still
we go.
pretty glare.
So cool. So the next thing would be to say, okay, well, setting NeoPixel 0 is good. Setting NeoPixel 1 is good. 2 through 15 are all the same. And so we can simplify the code by doing a loop. And the easiest loop in MicroPython is a for loop. So you do things like for some variable, and then we either increment it or we do something else. And so let's take a look at the syntax of a for loop.
It'd be a range function.
Yep. So Bob, you want me to talk while you type, or do you there we go. He'll just do it right there.
Is it
Parentheses.
2-16? Oh, it's
Parentheses.
2,
Comma.
16?
15.
15.
And then if you want to do a step, which you don't want to do in this case, but you could theoretically,
You want a colon, Bob, on line 7, go
Thank you.
colon. Yep.
and then just change.
Programming blind.
Yeah, you can get rid of 9 through the rest. 9, all those get deleted.
You're right.
Leave the right.
And just
And
put
then change-
I inside the.
Yep.
Yep,
inside
bingo.
the list.
So what
Do I
this
want to
now
write
does,
after the whole, after the, yeah,
after
outside
the loop,
No,
yeah.
You want to write after the loop because this is important
Yep.
too. So when you write inside the loop, it's going to literally write one at a time. If you want to set all your parameters at one time, then you would write after the for loop. So that way, it depends on what your goal is. If you want to make a
Let's
make a
do
little
this.
I was gonna say, do a little sleep thing and yeah.
I gotta import
pick-
sleep.
Yeah, the
I'm
other thing
sorry.
is the other thing to do is to pick a different color so that we'll actually see your ring.
Bob, you'll need a from you time import sleep.
That's right, that's right.
I'm importing all of UTime and referring to it as UTime
okay.
sleep. That
Oh,
works
yeah.
too.
That's cool.
There's lots of ways to skin all the cats in MicroPython.
So Bob, that's not gonna really look any different because
What did I fail on?
no, you didn't fail on anything. The pixels are already blue. So if you were to change,
No, I got a syntax error.
You do.
oh, when did the
um,
syntax
So
import machine NeoPixel and UTime?
you have
It's
you
back
time and then you're calling you time sleep.
Yep. Let's break it out and see if it,
Then you'll know which line it is. Yeah,
Yeah,
quick little debugging.
16. There is no line 16.
Are
Oh,
you,
There we go. Got it
What did we
working.
screw up? Come on, geniuses.
okay, so are you on try.me.py? Is
Huh?
that the file you're on, try.me.py?
It's really hard for me to move things around, but yes, that's what I'm
Okay.
on.
Okay. Standard input.
Because I've got like
16.
a little bit of a zoom window covering up part of my Thani.
Yeah,
So
you know.
something is, right. So something,
And 16, huh?
huh? That's interesting. I wonder what.
so, yeah, so it's not
Probably something
calling,
silly.
I'm
Yeah,
sure dude, we're all going to sit here and read the code to see if we can figure out what it is.
May I ask what's going on?
so what we're trying to do is we're creating a new Python file. And we're creating an example of a loop where we iterate over a range, which
Maybe-
is,
We took
But-
the code that display gave us, which individually sets each pixel in the 16 pixel ring. And we changed that into changed the third part of that into a loop.
So
But, we screwed something up.
I don't know what's going wrong. I'm gonna paste what I wrote, and that one I know works.
What-
It's almost identical, but I can't
All
identify.
right, where's it
That's
not
all right.
identical?
It's in Zoom chat.
Yeah, but the question is how did you import? Did you import UTime or did?
Oh, yeah, I imported UTime, machine, NeoPixel, and UTime all in the
So-
same line.
so
Okay.
Bob, if you hit Control S, Bob, and you run it, it should
What does Control S do?
save it.
File save.
Because right now it's showing an asterisk over on.
Yeah, it saves every time I hit run. So that's another thing about Thani. You can save individually every time you make a change, or when you hit run, it'll just auto save if you are working on an already saved file. It will save before it runs every time.
Now it's on line 19.
Yeah, so what I think's happening is I think another module is overtaking this try.me.py, and we're not even getting to the try.me.py. So we might want to close
I
out
don't
these
know.
other.
No, it's not. I'm definitely highlighting try.me.py. I can
Yeah,
I
don't
guess it
think-
won't
quick
run anything if
question.
it gets a syntax error somewhere,
So-
but it's definitely running try.me.py. I can kill the rest, but I mean, I've been through this stuff enough to know that it's
Well, and it
oh,
was
look at
working.
this. This is a good opportunity. So I can highlight try.me.py, right click on that, close others. That's really handy.
That is handy. I haven't seen that one before.
That's what I was trying to.
Yeah, sure, why not? I don't know what I broke, but yeah. So now we're only running try.me.py.
Line 21. Does it need
And
a, this is a silly question because I'm not totally fluent on MicroPython by any means. Does it need a blank line at outside of like after line 18 so that it knows that that loop is done?
No, it's
No.
based on tabbing. Maybe it's something to do with the tabbing.
No,
Like,
it's seeing
may-
it.
oh.
No, it's seeing another file for whatever reason. I think this is a bug inside Thani, is what I was trying to say. I think if we close out Thani and reload it, Bob, that'd be the first step on debugging it.
It seems kind of superstitious, but I am
Well, I'm gonna
game
post
for
a-
anything at this point.
Well, Thani
a
is
screenshot
Thani
of
is
what I have in the MicroPython Discord chat.
We got what
Well,
you got.
we can see it right in front of you. It's orbiting around, which is really pretty cool.
Yeah.
Share screen, Thani.
Very
All
cool.
right,
as a
can you
matter of
see me
fact.
again?
Yep.
Mhm.
All right, so I've got my try.me.py loaded.
Oh,
it has
now we
more
have now we do
lines than it had
now we have a
before.
bunch. Yeah, now we have a bunch of new lines. I think it was that copy paste that may have caused
There
us.
was some other broken spacing in there somewhere that was invisible.
Yeah. Okay,
So
cool.
now we'll know where the actual problem
Oh
is.
yeah, now 20 and 21 makes sense. There's no indentation.
That's it. That's what it
There it
was.
is.
It was a broken indentation in the for loop. Wow.
Woohoo.
So no more cutting and pasting in Zoom chat, people.
All right.
Eat me. Here we go. So
I
now
don't want to take up too much more time because we're already like, we're like 18 minutes till the end of the class and I haven't even gotten to the display yet. So
do you want to do display or buttons?
I could do buttons if we can get through it real quick. Yeah.
Well, there's one thing I would like to just touch upon.
18
Thani-
minutes, Kevin. Go ahead.
So Thani is still in massive rapid development. And when you see anything referencing a line that doesn't exist, closing it
Then you
out,
know something's wrong. Yeah.
right? But closing it out and then reloading it is going to be your best way so that you can kind of see what is actually local, because it is not actually refreshing the GUI or the UI, so to speak. So
What they need is a fixed spacing button. If you've imported something badly like we did, that it'll highlight that and let you
So-
know. Because
so the-
visually it looked fine, right?
right, but the biggest issue is it wasn't updating the UI in a way that it should. It's a Thani bug.
Yeah.
So that's all. Just in case you get this, just reload Thani and you're good to go. That's all.
Good learning stuff. Okay, so where am I getting button code? Brady?
Where can I do it so you don't have to? You actually have the file.
Try Discord. It shouldn't be a long code anyway.
No, it's not. It's not. Okay, so let me just
Either
gotta
direct or in the class channel.
I'll put it in the class channel. I'm just trying to find the class channel. I was just my screen is large and my mouse is small. We'll just leave it at that.
Sounds like a personal problem.
There you go.
All right, that looks good. Is that? Oh, there's more to it than that. Okay, so I have to actually click it, expand.
You got to get the
Okay.
and use whatever pins are going to be used for your buttons. I just happen to use the
I
two.
All right, I think I used 10 and 11 for mine.
That's fine. So yeah,
So, okay. 10, 11, right? We good? And that should be all I need to do?
Yep.
Okay. Let's see what
why does
happens.
the indentation doesn't look right?
Because I imported it and that happens. Let's see what
Okay.
happens.
So can I give a comment real quick?
Of course, you don't need to
So-
ask permission to give comments.
Well, so because we're doing pull up, this is really important, everybody. So we're doing a pull up resistor. It's an internal resistor. We don't have to get so much into resistors, what that means right now. but
Mhm.
we're specifically doing a pin pull-up. If we were not specifically doing a pin pull-up, we would likely have to do if button value is not equal to 0 or change that functionality. But because we're doing an internal pull-up, this particular code will work. So it's a larger conversation on what pull-ups and pull-downs and open drain and all these other conversations are, but just so you understand, to get this to work, it's important that you use the internal pull-up in order to have the button value equal 0.
Yeah.
That's all.
Yeah, so by setting it to pull up, the default for a button that's not being pressed is going to be some value. And when you press it, the button goes to ground, right? So now all of a sudden it's got no value or no voltage, and so the value will be 0.
Mhm.
So that's why I wrote the code this way. It requires no additional hardware on the end of the your pegboard, pinboard.
And I think this is more verbose. I think this is a good way to write code, if I can reinforce Braden, because it's explicit that if button value equals 0, well, it's not being touched, right? So it's pretty explicit. So this is kind of a good way to write your code. It's easier to read.
Yeah, and so for anybody who wants to play with this code, Bob, can you just show the while loop section for a minute there, the while true? So when I first wrote the code, it didn't have comments, right? It's good to add comments to your code. Second, I didn't keep track of press being true or false. So I just simply said if button 1 value equals 0, then turn the LED on and print out the message. And what happened was down in the little shell window down there, you're pressing the button. Well, it takes almost no time for the code to process that and come back around in the while loop and check it again, and it was still pressed. And so what I saw down in the bottom was button 1 press, just over and over and over again until I stopped pressing it. So by virtue of tracking that, you're going to get a compiler error now.
Can I also add one more
Yeah.
thing, if I could? So
Yeah, go ahead.
this is very C-like. What we want to do in Python is what we call the issue of truthy or falsy. It's called truthy or falsy. And what I would do to change this code to be more Pythonic, there's a word Pythonic, is on line 19, I would simply use if not pressed. If not pressed.
Well,
And
let's before we get into the details of it, let's get this working right, because it's
Yeah,
not
well-
working right now, and I'm
What
not
do you mean
sure
it's
why.
not working? What do you mean it's not working right?
So as you're like, so I'm right, I'm not pressing anything, and it says button 1 pressed, right?
hold it.
And I'm not sure if that's a wiring issue.
Well, what, so your button is wired to a pin, and then what's the other side of the button wired to on your pegboard?
To ground.
Then it should be, it sounds like it's a wiring issue, but I'm not sure. Because with the pin being pulled up, the button value,
And when I press 2, all that shit happens, because it thinks it thinks button 1 is pressed all the time, apparently. So I don't know what's going on here. Let me try a different pin. Not a different pin. Let me try the other leg of the button and see if that makes a difference. 1, 2.
you know, I have the advantage of, I know my board was wired correctly because Bob built it.
Yeah, I don't know which one's 1, which one's 2 either, because hard to see in this thing. So we don't have a currently working example, but that's okay. Let me pull up my pin out and make sure I have it in the right thing. Another thing is bad eyesight, not a good thing for PCB design.
No, my wiring bench has many pairs of magnifying glass lenses.
Same here.
My favorite discovery was safety glasses with cheaters built into them.
Right.
All right, well, I'm not going to troubleshoot this any further. I want to get into the next section because we only have 10 minutes left. And Well, I will publish working code somewhere afterwards. But it's really simple stuff once you get it, and don't have time to troubleshoot right now. Pull up my SSD. Why is my SSD not coming up? Oh, because my program's still running. Stop. Okay. All right, so this is SSD 1306. And this is a single uh-oh. Is that right? Oh, that's why. All right, so you look up here, you see where it says display demo. Can you see my mouse moving?
Mhm.
Okay, so this is on my local, in my local file system. And I thought, because I was looking on the Pico down here, and I didn't see my display demo file, I thought I had lost it, because that happens sometimes. But no, it's over here. So this is one of those things where SSD 1306 is a module, and it takes all the complicated stuff out of your code and just keeps it in a module. And you can write really simple code in relatively in your code and refer to the module by importing it. So let's see if this works. Yay, it works. Is that visible? Is that screen sort of visible? I know I got wires covering part of it up.
This is my favorite display of all time.
Why do you say that?
Because I love it because
Because it's easy.
It's simple and it's beautiful and it's elegant.
It's not beautiful or elegant. So let me say these SSD 1306 are monochrome displays. You can either get them in, white, yellow, green, whatever. And for the Tree of Life badge, I found this one that's like the top quarter of it is yellow and the rest of it is blue. And if you design your imagery and your text that you're displaying on it with that in mind, you create the illusion of having a multicolored display, when in reality you're using this display that, in quantity from China costs about $1, maybe $2, as opposed to the screen we used for this year's badge, which is like $8 a pop. 8 to 20, depending on if you buy it in the US. And okay. So I don't know, how deep do we want to go into how this display works? This is using I2C or I2C. How does everybody refer to that?
I2C. I2C.
Which uses a lot fewer pins than SPI. If you have one of these displays, in this example, I put clock, which in the code says SCL, but on my particular board says SCK. It's the same thing. Clock on pin 9. I put data on pin 8 of the Pico, and then power and ground accordingly to the rail again. And then this code just worked. And it's not very much code. Does everybody have one of these?
I know I have one, but
I do. I just haven't wired it up yet.
Okay.
exactly.
So this demo came straight from the internet, from one of the MicroPython pages. There's nothing fancy. We could pull like the Tree of Life demo out, the badge, and show some of the stuff we did on that.
The one thing I would point out is, as we were discussing with NeoPixels, MicroPython now has a machine kind of library for the SSD 1306.
Oh, so you mean something that's built in that takes the place of this?
Yeah.
Yep. All
Like
that.
the
All
name-
that's.
name of it.
Did that come with 1.19 also?
Yep.
Oh,
Well, I'm looking at 1.19 documentation and that's where it is. I put a
Yeah.
link in the Discord for anybody who wants it. There's a great example already in there.
there you go, Kevin. Rewrite the Tree of Life code. Use the built-in
that-
libraries.
Yeah, from the link from the Discord, it will take you to a tutorial on the SSD 1306. You'll need to specify the correct pin for SDA and SCL when you define your object. And then the resolution will be the same. I think all of us are using a 128 by 64. But then there's examples for putting text on there, drawing some lines, putting pixels, horizontal, vertical lines.
The cool
and-
thing about the 1306 is that in code, you can set it up so that your text or your image scrolls across the screen.
Mhm.
And that's a really nice feature. It's like you're writing it off the screen and then gradually rewriting it on the screen in different positions, and it just scrolls across. And it's very easy to do that. And there's a lot of code examples on the internet for doing that. And it's a nice little display. It's nice if you build a housing and position the display to be inset in the housing. Unlike what we did. Braden, do you want to show the Tree of Life badge since you have one? Do you have it handy?
Yeah, but I don't have a camera set to it right now.
Okay.
I have a Tree of Life badge that I can use.
Okay.
If you walk me through it.
Yeah, please.
Well, just,
yeah,
just turn it on.
Yeah.
course.
Yeah, I mean, if you want to use it for the class, I posted a picture. I made a label for the back of mine to remind me of what all the pins are that I'm using.
Yeah.
And that's in the Discord. So, the NeoPixel's pin 11, the OLED is pin 12 and 13.
I get
And,
emotional every time I see this. It's so beautiful.
Oh, it's so cool.
What, the Tree of Life badge or the fact
Yeah,
that we're
it's
hacking them?
It's just a beautiful badge. I just love it.
Can you
So,
zoom in on it or put it closer to the camera? So
Yep. So because that's got a Raspberry Pi Pico built into it, you can control those NeoPixels just like the class exercises here. And it's got 6 buttons on it, and you're going to be able to use the matter of fact, the code that Bob was showing is the code to control those buttons. And so the next step will be controlling that OLED display that's on there.
I'm trying to see
yeah,
if
and then
I
you can
have-
make that
Oh.
that Tree of Life badge do whatever you want. And there's 10 main LEDs that cover the spheres, but there's another 22 LEDs that cover the spaces between the spheres. So
Yeah, there's a total of
so-
32 in here somewhere.
Yeah. You can make some pretty cool effects once you figure out, wrap your head around managing them and writing code that does fun, random or not so random stuff. And that's what we did. We wrote code that sort of does hex circling around the center pillar. Just for the demo there.
I never did ask, but I think I know the answer. The add-on, the simple add-on header on there, that's just power and ground, doesn't have I2C hooked up, correct? On the Tree of Life badge?
It may or may not.
That's cool.
I may have extended it out there because that's what the spec said to do. I'd have to check it in KiCad and look. I'm pretty sure I did throw 2 GPIO pins out there as the spec intends. So yeah, I believe I did.
No, it's labeled for I2C and GPIO 1 and 2. Cool. So yeah, you
Well,
can
that's
even
not
plug.
that doesn't mean actual GPIO 1 and 2. It's just 1 and 2 for that shitty add-on.
Okay, fine.
You'll have to look at the spec.
I'll
to
go
figure
back.
out
I'll
which
go
pin
back.
it is.
I'll go back and double check it. But it's kind of cool then. That means that if you're using the Tree of Life badge for this class, you'll be able to do other I2C or IC squared tasks by plugging into the header pin.
Maybe I'll use it for next class instead of messing with the wires here a little bit.
We're done with breadboarding at this point. Next class we're gonna get into the KiCad stuff and yeah, I don't anticipate doing anything else on the breadboard unless we run out of time at the end and people want to explore further and do further stuff. I think we've covered most of the stuff. We'll publish the code. The recordings will be available, so anything that you need to go over again, you could watch the recordings, or you could come back later if there's something we didn't address. But we're gonna
Okay.
start with KiCad basics, KiCad navigation next week, and then move into, you know, parts placement and routing, and then getting it ready for fab. And so 4 weeks from now, you should be able to send something to China and
Hopefully
get an
they'll
order
get
in.
it right.
Yeah. I mean, if they don't get it right, generally you didn't get it right. That's my experience.
Yeah.
When they didn't get it right, it's because I didn't get it right.
We'll
Hmm.
find it. We'll find out soon enough.
Yep. Yeah, I look forward to the RP 2040 example that you're doing, and you ended up getting, you're going to build that yourself, right? You're going to pick and place that
Yeah, I'll
yourself?
hand it. I'll hand it. It doesn't have that many parts on it. I'll hand assemble it. I mean, it's got, you know, like, I don't know if it's got 30 or 40 parts on it. It's not bad.
Is there anything anybody wants to go back to tonight, like right now, before we shut this thing down? I want to respect everybody's time.
I think the recording can be a good substitute for what I whatever I was missed while I was distracted messing with the breadboard and the NeoPixels.
Okay, so what I'm doing with these recordings is I cut it down to, you know, cut the beginning and the end off,
Mhm.
and I put it up on YouTube as unlisted for now, not public, but unlisted. And then I published the link in the Discord channel. Probably when the whole series is over, I'll get all y'all's permission, all you regulars permission. And if y'all are okay with it, we'll make them public. But, you know,
Okay.
some people have a problem with that, you know, having their face on a public video. So I'll leave it up to you guys. The way the video seems to work is that the only thing that's highlighted is the speaker who's speaking. So if you didn't talk much, you're not going to show up much anyway. Does that make sense to everybody?
Mhm.
Mhm.
So probably should have had that conversation off screen, but I wanted to
doing
address
this
it since I
live.
was thinking of it. Yeah, real time, man. We're winging
Just
it.
edit it out.
And also, there may or may not be subliminals in the final product. We'll see.
There will always be subliminals, whether you like it or not.
Right.
just
Whether
don't know
I put
about
them
it.
in or YouTube puts them in, you know, there just might be something there. Drink Coke. You know, I just
Consume.
obey.
I
All
need a
right.
better
So
advance for it. Yeah.
if there's nothing else, I'll shut it down and see y'all next week.
Thanks,
Yeah.
Bob. Thanks, everybody.
Thank you, Bob.
Fun.
Ah, this
right.
is fun.
See you next
Later.
week.
Bye.
Later, y'all.
Bye. All right. Okay, and that mess.